Okay, what are the solutions of the inequality? And we're going to graph it. This highlights a very important concept that you need to get right. So hear it, watch it over and over again until you get it. Ask questions about this one. This is a big one. Okay, check it out. What's happening to x? Well, it's being multiplied by negative 1/8. And remember, if we want to undo a fractional coefficient, we can multiply by its reciprocal, okay? Because essentially what's happening is it's being multiplied by 1/8, and also we got to undo that negative. So we need to multiply by the reciprocal of negative 1/8, which is negative 8. Okay, the negatives will cancel out, and the 8 times 1/8 will give you that 1 that you need as your coefficient of x. Okay. However, we are now multiplying by a negative. And this is the big thing that we've been talking about that you need to watch out for. If you multiply or divide by a negative number, at the exact same time you do it, you have to flip the inequality to the opposite direction. Got it? We're multiplying by negative 8. We're going to multiply this side by negative 8 as well. And since we're multiplying by a negative, the inequality changes direction exactly at that step. Okay, now, negative times negative is positive. The 8 and the 1/8 cancel out to give us just 1x or x. Now that we've flipped it, it stays flipped. Okay, and we've got x is greater than negative 40. So when we want to graph that, we could say negative 40 is right there. Okay, and I'll just put some other marks. Say negative 39, negative 38, negative 37, negative 36, negative 35. Negative 34, negative 33, negative 32, negative 31, negative 30. Just to give some points that, oops. Okay, and we can go the other way. It doesn't really matter. This is less important, but negative 41, negative 42, negative 43, negative 44, negative 45, and negative 46, negative 47, negative 48, negative 49, negative 50. Okay, but what's important here is this bit right here where we multiply by a negative and therefore we flip the direction of this from opening to the right to opening to the left. Okay, so we've got an endpoint at negative 40. Can it include it? Yeah, because it says or equals. So we fill that in, and x is all values that are greater than negative 40. So that is on this side of it. That's how you graph it. Okay, let's see what happens with the next two. Okay, so unlike the last one, you can see that there are negatives in here, but we're not multiplying or dividing by a negative. What we're going to do here is we're just going to simply add 3, add 3. Doesn't matter that you see negative numbers. It's whether you're multiplying or dividing by a negative that makes the inequality flip. And we're not multiplying or dividing by a negative. So the inequality does not flip. And we simply get b is greater than 2. So let's put a 2 there, 3, 4, 5, 6, 7, 1, 0, negative 1, negative 2, negative 3. We have an endpoint at 2. Do we fill it in? No, it does not say or equals. It just says b is greater than. Greater than is on this side. That's how you graph it. One more. So, sorry, I came back to this because one thing it asks us to do is check the solution. So we have a two-part proof. And two-part proofs look like this, okay? The first part of the proof is to take the original equation, or sorry, the original inequality, b minus 3 is greater than negative 1. And what we want to do is we want to check two things. We want to check, is this the right endpoint? Is 2 the right endpoint? And then, did we shade the correct side of that? So the first thing we do is we plug in that 2. And when we say 2 minus 3 is -1, -1 is greater than -1. This is not a true statement, but that's not at all, doesn't matter. That's not what we're looking for. What we're looking for is that we get the same number on both sides. If we get the exact same number on both sides, then this inequality is ending at exactly the right point. Okay? Do we get that exact correct endpoint? Yes, because these numbers are the same. Okay, so that first part of the proof checks out, same number on both sides. Now we're going to do proof number 2. Proof number 2, we go back to the original inequality. And now we just pick any number that's on the side of the inequality that we've got. Okay, anything bigger than 2. So we can pick 3. Why not? It's bigger. Okay, let's pick 3. And when we plug in 3, we say 3 minus 3 is greater than -1. 3 minus 3 is 0. Is 0 greater than -1? Yeah, 0 is greater than all negative numbers. So check, that worked out. The two-part proof looks like you check the number itself that you got here in your solution, plug it in, and see whether you're getting the same number on both sides. If you're getting the same number on both sides, you're good. Okay? If this doesn't say or equals, it's not going to be true, but it doesn't matter because all you have to do is get the same number on both sides. -1 and -1 works. That's the first part, checking the end point. Then the next part is which side, like did I shade the correct side? And so what do? You pick any number that's on that side, plug that number in, and it's got to work out to be a true statement, and it does. So, okay. What's happening to J? We need to solve this. Okay, so what's happening to J is it is being -3/8. 3/8 is being subtracted from it. So we have to undo that with a +3/8. +3/8. Okay, and so then what we get down here, well, we get like that for the J. And I'm going to do this over here on the side. Well, I'll do it here. 7/10. We've got 7/10, and we've got +3/8, right? Because we took 7/10 and we added 3/8. Now, the trick is we need to have a common denominator. What's the common denominator? Common denominator of 8 and 10? It's 40. Okay, so we need to turn these both into fractions with 40 on the bottom. Then we can add them together. And 7/10 is equal to 28/40, multiplying top and bottom by 4. And 3/8 is equal to 15/40, multiplying top and bottom by 5. Now when we add them together, we get 43/40. Okay, otherwise known as 1 3/40. Okay, but I'm going to keep it as 43/40 for now, and I'm just going to say this. We're going to go by 40ths here. We can say that this is 40/40, otherwise known as 1. Okay, so this is 41/40, 42, 43, 44, 45/40, going by 1/40 every time. Okay, keep going, 46, 47, 48, 49, 50/40. And going in the other direction, we could say 35/40 here. And 30/40 here. Of course, these fractions could be simplified, but that's okay. Okay, 40/40, which again is otherwise known as 1. That's 1, right? 43/40 is right here. Okay, can we fill it in? Yes, it says or equals. And is J values greater than that or less than that? J is on the small side of the inequality. J is less than that. We're talking about all values less than that, just like that. Okay, and it says check the solutions. So what it really wants us to do is plug in. First, we got to do a two-part proof. Okay, so I'm going to write the original inequality. 7/10. I know this is tricky because it's fractions, but that's okay. We're practicing fractions. We need to. Okay, 7/10 is greater than or equal to j, and I'm going to replace j with what we have as an endpoint, 43/40, and minus 3/8. Okay, with this first proof, what we're doing, and I should write proof here. With this first proof, what we're doing is we're trying to see whether the endpoint is correct, and if it is, we should get the same number on both sides. Okay, so 43/40 minus, what's 3/8 in 40ths? That is 15/40. Okay, and so that's the same as 7/10 greater than or equal to, what is 43 minus 15? 43 minus 15 is, let's see, 38/28. 28 over 40. And actually 28 over 40 simplifies down to 7/10. So we've got 7/10 is greater than or equal to 7/10. The goal is not to see whether this statement is true, because it is, because it says or equals. But even if it didn't, what we're looking for in this first proof is that we get the same number on both sides. We do. So that means that the end point here is in the correct place. Now we got to pick a number less than this, okay? And because it says values less than that are also part of the solution set. So we do another proof. Do proof here, proof. And we take the original equation, 7/10 is greater than or equal to j minus 3/8. Okay, and what I'm going to do is I'm going to pick a real easy number that's less than 43/40. Some of you might be thinking 40/40 or 1. Yeah, you could do that, but I'm going to pick something even easier, which is if you went far enough down, you'd get to 0, and 0 is a super easy number to check, because 7/10 is greater than or equal to 0 minus 3/8. Okay, and that means that 7/10 is greater than or equal to negative 3/8. Is it true? Yeah, it is actually true, because any negative number is always less than a positive number, so check, and this one checked out too. We did our proof, and we're good.